All right, our last formula to learn today for chapter 11. We're finding area and perimeter of lots of objects. This section is all on regular polygons. Remind me what regular means. Yes, all the sides are the same and all the angles are the same. So on each of these pictures here, we're going to draw two segments. We're going to draw the radius, which is the distance from the center to any of the vertices. Okay, so let's just draw a radius on each one. It doesn't matter what corner you draw it to. Starts at the center and it goes to one of the corners. This is considered the radius of the polygon, because if you were to draw a circle around it, it would be the radius of the circle. That's why it's called the radius. Okay, so that's the radius, and you can draw it to any corner you want. The segment that we're going to use in the formula is called the apothem. The apothem starts at the center and goes perpendicular to a side. Okay, so what you're going to do is you're going to draw that next to wherever you drew your radius, okay, and label it with A. And it can go to any side, but you're always going to be creating these right triangles inside your regular polygons. You're going to be using those right triangles. Okay, and just glancing around at a few screens, some of you are drawing another radius. You need to go perpendicular to a side so that there's a right angle with the apothem. Okay, so some of you are going to have to erase what you just drew because you actually drew two radii. The perpendicular is on the side, not at the center. Okay, so this right angle right here is perpendicular with the side. The apothem and the side are 90-degree angles. Okay. All right, here's our formula. Last one for this chapter, 1/2 AP. A stands for however long that apothem is, and then P is the perimeter of the regular polygon. So we need those two values each time. Okay, so we're going to try this. We'll try it with these two first. So we have a pentagon. All of these are regular polygons. We're going to assume that. Okay, so we've got A equals 1/2 AP. Always write the formula first. What is the length of the apothem? This is the perpendicular segment to the side, so that is 4. What's P stand for? The perimeter. What's the perimeter of this shape? It is 25. Each of the sides is 5, so the total distance around is 25. We end up with 50 for our answer. Okay, so we always need the apothem and the perimeter. The next one, just written in word form instead of a picture. What's a decagon? 10 sides. Okay, so we write A equals 1/2 AP. A equals 1/2. Okay, we keep reading. A regular decagon with an apothem of 5.4 inches. Put that right where the apothem goes. And each side is 3 inches. So do we put 3 right here? No, we put the perimeter, which would end up being 30 if there's 10 sides and each is 3. What's this? $81 even? Questions? Now, you're not always going to have the apothem and the perimeter automatically like we just did in these two examples. Okay, more often than not, we're going to have to find that information. So I'm going to go through some examples of that. So on this one, let's start, because we automatically put the formula down for whatever shape we're looking at. We're going to put in what we do know. Okay, so we set all of this up. We get our formula down. We have our parentheses where we're going to put our two numbers we need, and we'll leave the answer blank. Now, what information are we able to find from this picture? The perimeter. Now, each side is 18, so our total perimeter is 108. Okay, what are we missing though? We're missing the apothem. Okay, so we're going to draw that in right here. We want to know this. So I'm going to go through a process right now that you're going to do on every single problem if you're missing any information. Okay, we're going to draw in the apothem. We're also going to draw in the radius. Now, we don't need the radius length. We're just creating a right triangle. Okay. How long is this right here? Everyone sees that it's 9. How is it 9? Yep. Yep, each side is 18, so we cut that in half. Now we know that's 9. Okay, next thing you're going to do is figure out how big this angle is. Let's think about this. If we were to draw all of the triangles that look just like this inside of this hexagon, if you drew all of the radii and the apothems, how many would there be? How many triangles are there that are exactly the same? I hear someone whispering it from the back table. There's 12. What's a really easy way to figure that out without drawing them all? There's 6 sides. Every side has 2 triangles on it, so we times that by 2. There are 12 triangles. Okay? If we want to figure out just one of those 12 angles that equally got cut up in this circle, we would take what divided by 12? 360. That's a full circle, right? So we take 360. We divide by how many triangles there are. If we were to draw them all, we're not going to draw them all from now on because we know the shortcut. We take the number of sides times 2. And we get this angle right here. What's 360 divided by 12? 30. Now we know this angle right here is 30 degrees. What are we going to use? SOHCAHTOA. Okay, so let's review this. We've got our angle. What side is this? This is the opposite side. What is this? Adjacent. So which one uses O and A? TOA. Okay, so off to the side we'll go tangent what? 30. The angle always goes here. And then what order does this go in? If you look over here, it'll tell you. Has to be opposite over adjacent. Okay, what do we always do to solve these? We always multiply by what? Yep, whatever's on the bottom, the denominator. So that is x on this one. So now we have x tan 30 is equal to what now over here? 9. Is x by itself? No. So what do we have to do? We divide by tan 30. Now we put this in the calculator. How long is the apothem? All right, so that goes here. And now we can get our answer. Someone throw that in the calc. Questions? Yep.
So did you just find the area of each of the 12, or of one of the 12 triangles by 1/2 based on site, and then multiply by 12?
You can find one of the 12 triangles, 1/2 base times height, and times by 12. Yes, you can, as long as you show your work. To me, this is a little bit quicker. Once you find the apothem, you just throw it in the formula. but that works too. All right, let's try this one. Another regular polygon. This one's a triangle. All three sides are the same. We need to draw in the apothem. Make sure your right angle is on the side, not at the center of your picture. Okay. We need to find the apothem. Let's figure out how big this angle is right here. Okay, how many triangles could you draw just like this one inside? 6 of them. Okay, so how would we find one of the 6 angles? 360 divided by 6 gives us 60. Okay, so we have a 60-degree angle right there. What 2 sides do we have? 10 is the, I heard somebody whisper it, hypotenuse. What is x? Adjacent. Which one has a and h? Ka. So we're using cosine 60 is adjacent over hypotenuse. We multiply both sides by 10. Is x by itself now? Yes, it is. So we don't have to do that extra step of dividing both sides by something. We put this in the calculator to get what for an apothem? Okay, so we just figured out the apothem is 5. Let's start our formula here. We still need to figure out the perimeter. Now we don't have any of those segments on the outside. Let's look at this triangle we drew on the inside here. I'm going to redraw it out here because there's a lot of stuff written on it. Okay, we have 5 and 10. We could do another SOHCAHTOA if you would prefer that. What's the other option at this point? Pythagorean theorem. Which one do you want to do? Pythagorean theorem, okay. Which one is c squared? 10 is, so we go 5 squared plus x squared equals 10 squared. 25 plus x squared equals 100. Subtract 25. X squared equals 75 and square root. That part I need help with. Okay. So this we just figured out is 8.66, which is right here on the triangle. How could we find the perimeter? We double it to be what? What's 8.66 times 2? So each side is 17.32. We take that number times 3, because there's 3 sides. What's our total perimeter? That's our perimeter. What's the total area? Did I write it down right? Is that what I heard? Okay. Questions on that? You're always looking for the apothem and the perimeter, and then you can get your total area. Am I going too fast? Okay, this one. Draw in the apothem. Put our x on the apothem, because that's what we're looking for. How big is this angle? We would do 360 divided by 8. Okay, so we have a 45, 45, 90 triangle. I'll use that in a little bit. But we're looking for the apothem right now. So what 2 sides do we have here? Here's the hypotenuse. Here's the adjacent. So we're using cosine again on this one. cosine 45. What's the order of the fraction? X over 12. Multiply by 12. What's 12 cosine 45? What is it? All right. So we just found the apothem. Let's start our formula off to the side here. And we need the perimeter. Now before I said we have a 45, 45, 90 triangle. So we just figured out that this is 8.49. How long is this? It would be 8.49 as well. That only works on the square, okay, because we get a 45, 45, 90 triangle. So we have 8.49, which means the whole side is which means we can times that by 4. And we get what? And then we get what? Confused on what part? On the perimeter?
No.
What's this answer? How much?
288.
Questions? Really, the process is going to be similar each time. You're needing to find whatever information is missing. You're going to be writing down the angle measure each time the same way, just figuring out 360 by how many triangles you could draw, and then using SOHCAHTOA. Okay, we're going to try 2 more just to make sure we're good with this. Process is going to be the same. On this one, they gave us the radius. We're going to draw in the apothem, right angle down on the side. How big is this angle here? It's 30 degrees. We take 360 divided by 12 because there's 12 triangles. That gives us that 30. All right, what are we using? Sine, cosine, or tangent? We have the hypotenuse here and adjacent. So we have cosine 30. What order? Yep. Multiply both sides by 22. What's the apothem? How much? Okay. Once we have one of our numbers, it's good to start writing down that formula. So now we know the apothem. Okay, this is another one of those situations where we have options. We could do a squared plus b squared equals c squared, or we could do another SOHCAHTOA. What would you want to do? Pythagorean theorem? Okay, 19.1 squared. You're going to have to help me with these numbers here. What's this one? Give me all the numbers. What is it? Point what? Okay. I have 2 equal signs here. Okay, we'll subtract this. And square root. 10.92. Okay, so this right here, we just figured out is 10.92, which helps us find the perimeter. How long is each of the 6 sides? What do we do to 10.92? 21 point what? Okay. So that's what each side is. Remember, it's a regular hexagon, so we times that by 6 to get our perimeter. What is it? It's the total area. Got one left. Let's draw in our right triangle. All right, on this right triangle, do we know anything? You know this right here is what? 5. Somebody said we know the perimeter, so let's start by writing down our formula. Our perimeter is what? 50. Each side is 10. We just need to figure out the apothem, and then we have our area. So we know 5, we know x, and we can figure out how big that angle is. By doing what? How do we figure out how big that angle is? $360 divided by, there's 10 triangles that you could draw. Okay, it's not because this is 10, it's because there's 10 triangles. So we got 36 there. Sine, cosine, or tangent? It is tangent. We have opposite and adjacent with letters or variables, letters or numbers written on them. So we've got tan 36. What order does the fraction go in? It has to be opposite over adjacent. So we multiply by x. We've got x tan 36 equal to 5. X isn't by itself on this one. So we divide both sides by tan 36. What is the apothem? Okay, we'll go with 6.88. Now we can find the area. What do we get? Even? Okay. No units, so we don't need units on the answer. Any questions on 1/2 AP?